Good day, everyone, and welcome to our physics class. Our today's topic is rectilinear acceleration for senior secondary schools 1, first term, week 10, according to a curriculum developed by the Kano Educational Resource Department. I am the presenter, Shuaibu Muawiyah Salem Kano. Today's date is May 12, 2024. Now let us look at the learning objectives. These are activities that students should be able to do at the end of this class. At the end of this lesson, students should be able to, number one, define acceleration and rectilinear acceleration. Number two, they should also identify and use the acceleration formula, meaning they should use this formula to solve problems on acceleration. Number three, they should identify the SI unit of acceleration. This is a unit that is internationally agreed by scientists all over the world. Now, without any delay, let us look at the definition of acceleration. In the language of physics, acceleration is defined as the rate of change of velocity with respect to time. Acceleration is defined as the rate of change of velocity with respect to time. This means point number one, if an object velocity is not changing, you don't have acceleration, or the acceleration is zero. So if an object is at rest, is not moving, it has zero acceleration. Or if an object is moving with uniform velocity, constant velocity, again its acceleration is zero. But if the velocity of an object is now changing, you have acceleration. How do you measure that acceleration? You measure the change in velocity, the final velocity minus the initial velocity. That is the measurement we call change in velocity, and you divide it by the time it takes to change. This measurement is what is called acceleration, and the physical interpretation of it is that it means you want to know after every 1 second by what amount is this velocity changing, whether increasing or decreasing. So if I say the acceleration, for example, of an object is 2 meters per second squared, what I mean by that is that after every 1 second its velocity is changing by 2 meters per second, is increasing by 2 meters per second. If the initial velocity is 20 meters per second, it means in the next 1 second it will be 22, the next 1 second 24, the next 1 second 26, the next 1 second 28, and on and on. This measurement is what is called acceleration, the rate of change of velocity with respect to time. Now, what about rectilinear acceleration? Okay, rectilinear acceleration refers to the acceleration that occurs when an object moves along a straight path, meaning when the rod followed by an object is a straight one, the object is not rotating, is not bending, then the acceleration is called rectilinear acceleration. Generally, when we say acceleration in physics, what we mean is rectilinear acceleration, unless otherwise specified. Because if an object is rotating, then its acceleration is called centripetal acceleration. So the acceleration we will be considering in this class is entirely rectilinear acceleration. We are assuming that the object is moving along a straight path. It is not rotating at all. Now, what is the formula for calculating acceleration? For acceleration formula, here is the formula in words. Acceleration equals change in velocity divided by the time it takes to change. Meaning, if I want to measure acceleration, I will have to measure the change in velocity of an object and then divide that change in velocity by the time the velocity has taken to change. Now, in symbols, this acceleration is given a letter A, the change in velocity delta V, and then the time it takes delta T. Now, suppose the acceleration, the velocity of an object changes from U initial value to a final value V, then V minus U gives you the change in velocity, so you divide it by the time this velocity has taken to change from U to V. We will see that in an example. Suppose a car's velocity changes from 12.5 meters per second to 22.5 meters per second in 5 seconds, meaning this velocity of the car, initially the car was moving with 12.5 velocities, 12.5 meters per second velocity, and then this velocity begins to change, and after 5 seconds the new value of the velocity is 22.5 meters per second. So your initial velocity u is this 12.5 meters per second, your final velocity v is this final value 22.5 meters per second, and from there you can get the change in velocity delta v, which is final minus initial, and this will give you 10 meters per second. And remember, the time taken delta t is 5 seconds. So you can now apply the formula for acceleration and say therefore car's acceleration a equals change in velocity divided by the time it takes to change. You already got the change in velocity here, delta v, as 10 meters per second, so you substitute that delta v is 10 meters per second. The time taken, delta t, is 5 seconds, so you divide 10 by 5, you get 2 meters per second by second, you get meters per second squared. So the acceleration, as we can see, it is a positive value, and because it is positive we can conclude that the car is speeding up, meaning its velocity is increasing, it is speeding up. Take again as an example that if the car's velocity changes now from 22.5 meters per second to 2.5 meters per second, meaning now it is dropping from this value to this value, and the time it takes to change from this value to this value is now 10 seconds, then your initial velocity u is this 22 meters per second, your final velocity v is the last velocity that you have here, 2.5 meters per second, and the change in velocity delta v is final minus initial, and 2.5 minus 22.5 will give you negative 20 in meters per second. Time taken, delta t, is 10 seconds. 10 seconds now. So the car's acceleration a, if you apply the formula delta v divided by delta t, your delta v now, you got negative 20 meters per second, you see, so you substitute negative meters per second, and the time it takes to change is 10 seconds. So negative 20 divided by 10 will give you negative 2 meters per second, divided by second will be meters per second squared. Now, because the acceleration has a negative value, we conclude that the car is now slowing down. So if an acceleration is positive, it means the object is speeding up, and if the acceleration is positive, the object is slowing down. What about the SI unit of acceleration? The SI unit of acceleration is the meters per second, or simply meters per second squared. Okay, and the unit symbol is this one or this one. Any one you use is correct, and each one of them is pronounced meters per second squared. Okay, we conclude our class today by these 4 important notes. First of all, an object at rest has 0 acceleration. Any object that is at rest, its velocity is 0, so it has acceleration has to be 0. Point number 2, an object moving with a uniform velocity also has 0 acceleration, because the velocity is not changing. Your change in velocity is 0, and because of that the acceleration has to be 0. Point number 3, an object that speeds up has a positive acceleration. We saw that in the example we gave. And finally, an object that slows down has a negative acceleration. Whenever an object is slowing down, it has negative acceleration. If it is speeding up, positive acceleration. And 0 acceleration means one of 2 things: either the object is at rest or the object is moving with uniform velocity. This is the end of our today's class, and I hope you enjoyed it. Assalamu alaikum wa rahmatullah.